Motion.
Good afternoon, classmate. Good afternoon, ma'am. So what is motion? So motion change an object position over time, and it's described by factors like distance, velocity, displacement, acceleration, and speed. So here's are the key concept of motions. The first is distance. So the total length of the path an object travels. Distance is the measurements of how far two objects are away from each other. So distance is the total length of the path an object travels. So it's a scalar quantity, meaning it only has magnitude, size, and no direction. So units for distance include meters or m, kilometers or km, and feet or ft. So here's are the examples of distance. So if a car travels 10 meters straight, then turns and travels another 5 meters. The total distance travels is 15 meters. So kumbaga 10 plus 5 is equals to 15. So the second is displacement. So the change in position of an object measured as a straight line from the starting point to the ending point, because displacement includes directions. So it's a vector quantity, meaning it has both magnitude or how far and directions which way. So it can be visualized as an arrow pointing from the initial position to the final position. So an object can move a significant distance, but if it ends up back to its starting point, so its displacement is 0. So here's are the examples. First is if an object moves 5 meters to the right, its displacement is 5 meters to the right. So the third is velocity. So the rate at which an object changes its position including direction. So the velocity is a vector quantity, meaning it has both magnitude or speed and direction. So the SI unit for velocity is meters per second or m per s. So the average velocity is the average velocity of an object is calculated by dividing the total displacements or change in position by the total time taken. So the instantaneous velocity. So instantaneous velocity refers to the velocity of an object at a specific moment of time. So velocity is typically measured in meters per second or m per s, or kilometers per hour or km per h. To have constant velocity, an object must have a constant speed and a constant direction. So examples, a car moving at a constant 20 kilometers per hour in a circular path has a constant speed but does not have a constant velocity because its direction changes. So you can calculate velocity by dividing displacement. So changing in position by the time taken. So number 4. So acceleration, the rate at which an object velocity changes. So it's a vector quantity, meaning it has both magnitude or how much and direction. So acceleration, when object velocity changes happen through, first is change in speed. An object speed up or slow down. So the second is change in direction. So even if the speed remain, so constant a change in direction means the object is accelerating or like a car turning. So change in both speed and direction. So a combination of both speed and direction changes. So there are two types of acceleration. So the first is positive acceleration. So indicates an increase in velocity speeding up. So the negative acceleration or deceleration indicates a decrease in velocity. So the positive acceleration is, di ba, speeding up. Kung ang negative acceleration is slowing down. So here's are the examples. So a car speeding up on slowing down. So the second is an object falling under the influence of gravity. So the third is an object can moving in a circle even at a constant speed because its direction is constantly changing. So the standard unit of acceleration is meters per second or m per s. So number 5 is speed. So the rate at which an object moves without regard to direction. So speed is typically measured in meters per second or m per s, or kilometers per hour or km per h. So types of speed. So constant speed, when an object travels the same speed for a period of time. So the average speed or the total distance traveled divided by the total time taken. So instantaneous speed, the speed of an object at a particular moment in time. So calculating speed or formula speed is equals to distance per time. So example, if a car travels 100 meters in 10 seconds, so its speed is 10 meters per second, or 100 m per 10 seconds is equals to m per s. Examples of motions. The first is a car moving the street, a ball being thrown in the air, the earth revolving around the sun, and lastly, even the movement of atoms and molecules. So they are the types of motion. So the first type of motion is linear motion. So motion along the straight line, or there are two types of linear motion. So the first is uniform linear motion. So in this type of motions, the object moves at a constant velocity, meaning it covers equal distances in equal time intervals. So the acceleration is 0. So non-uniform linear motion. So here the object's velocity changes, either speed up or slow down, so resulting in non-zero acceleration. So example, a car moving on a straight road at a constant speed. So a ball falling straight down under the influence of gravity. So an object sliding down a frictionless straight ramp. So number 2, circular motion. So motion along a circular path. So there are two types of circular motions. The first is uniform circular motion. So the objects move at a constant speed along the circular path. While the speed is constant, the velocity is constantly changing because the direction is constantly changing. So non-uniform circular motion. So the object's speed changes as it moves along the circular path. So to keep an object moving in a circular path, an inward directed force, so centripetal force is required. So this force what causes the change in direction or acceleration that is necessary for circular motion. So the acceleration required to maintain circular motion is directly towards the center of the circle. So example, a stone tied to a roof and swung in a circle. So second is a car turning through a curve. The third is the earth orbiting the sun approximately. So the fourth is a ceiling fan's blades rotating. And lastly, a gear turning inside a mechanism. So circular motion is a type of motion where an object follows a circular path. So in this motion requires a centripetal force to maintain the circular path and the object experience. So centripetal acceleration directed towards the center of a circle. So number 3, rotational motion. So motions where an object rotates around an axis. So first is rigid body. So in rotational motion, we often consider rigid bodies, which are objects that maintain a fixed shape and mass. So the second is axis of rotation. So the point or line around which the objects rotate. So example, the earth rotating on its axis, a spinning top, and a wheel turning. So rotational motion is related to linear motions because every point on a rotating object moves in a circular path, and a linear speed of point depends on its distance from the axis or rotational and angular velocity. So number 4, oscillatory motion. So motion that repeats back and forth. So a specific type of oscillatory motions where restoring force is directly proportional to the displacement from equilibrium and always directed towards the equilibrium position. So the first is period. So the time it takes for one complete cycle of oscillation. The second is frequency. So So the number of oscillations per unit of time or measured in hertz. So the third is amplitude, the maximum displacement from the equilibrium position. So in real-world scenarios, oscillatory motion is often slowed down by forces like friction, causing the oscillations to eventually stop. So here's are the examples of laws of motion. So the first is Newton's first law of motion. So an object at rest stays at rest and an object in motion stays in motion. So with the same speed in the same direction unless acted by an unbalanced forces. So the first law is inertia. So this law describes the tendency of objects to resist changes in their state of motions. So the second is object to rest an object. So that is moving will continue moving at a constant speed and in a straight line unless a force acts upon it, so causing it to move. So unbalanced force. So that is not counteracted by another force, resulting in a change in the object's motion. So the second is Newton's second law of motion. So the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So first is force and acceleration. So a force is needed to cause an object to accelerate, change, or velocity. So mass and acceleration. So the more massive an object is, the less it will accelerate for a given force. So a larger mass resists acceleration more strongly. So motion is an important concept in physics, which can be better understood by applying conceptual knowledge to solve problems. So did you know that everything in the universe is always moving? Even if you are completely still, you still belong to the earth, which is continuously moving about its axis and around the sun. So that's all my report, and thank you for listening, and God bless.